Do you know what complementary angles are? If you are just trying to get started, or you already know about that, you are in the right place. In this tutorial, we are going to be looking at trigonometric, and specifically, we are going to be looking at ratios of complementary angles. So let's get started. What we are going to be looking at now are the ratios of complementary angles. But before we proceed, what are complementary angles? To put it simply, complementary angles are two angles in which their sum is 90 degrees. For example, if you have 44 plus 46 is equals to 90. So we have that the angle 44 and 46, they are complementary angles. It can be in any form. If you have 40 and 50, this equals to 90 degrees. So 40 and 50 are complementary angles. So that is simply the definition of complementary angles. Now let's look at the ratios of complementary angles. To illustrate this, we are going to start by considering a right angle triangle. Okay, we have a triangle here which is labeled P, Q, and R. So this is the small letter r, this is side R, this is side P, and this is side Q. So the angle here is angle theta, and the angle here is angle alpha. We have our 90 degrees here. So this is just an imaginary triangle. Now from this triangle, the sum of angles in a triangle equals to 180. So if you have theta plus alpha plus this angle which is 90 degrees equals to 180 degrees. So we can have that theta plus alpha equals to 180 degrees minus 90 degrees. And this equals to theta plus alpha equals to 90 degrees. That is 1. And alpha equals to 90 degrees minus theta. This is when we have already collected the like terms. Let's take note of this relation. Alpha equal to 90 minus theta. Now that is the first part. Now the second part. According to this triangle, sine theta equals to the opposite of hypotenuse, and that's equals to opposite of hypotenuse. We have for sine theta, this is the opposite. Let me change this to theta. So sine theta equals to opposite of hypotenuse, and the last side is the adjacent. So for sine theta, we have opposite to be P over R, opposite of hypotenuse. So for cos theta, this is adjacent of hypotenuse, and we have the adjacent to be Q over R. For tan theta, we have tan theta to be opposite over adjacent, and this equals to P over Q. So that is that for angle theta. Now considering angle alpha, which is what we have here. So for angle alpha, we have this side to be opposite. That is where the angle is facing, and we still have our hypotenuse to be the longest side, which is the side R, and this now stands as the adjacent. Take note of this. For angle theta, we have this side to be the opposite. For angle alpha, we have side Q to be the opposite. Now what is sine alpha? This also equals to opposite of hypotenuse, and then we now have our opposite to be equals to Q of hypotenuse, which is R. For cos alpha, we have this to be equal to adjacent over hypotenuse, and this equals to the adjacent now stands as P of hypotenuse, which is R. And for tan alpha, we have this to be equal to opposite over adjacent. The opposite now stands as Q of adjacent, which is P. Now we have already established all these points. Now let's look at these definitions very well. We can see that sine theta also equals to cos alpha. They are both P over R. Also, cos theta equals to sine theta, sine alpha, and tan theta equals to cot alpha. Okay, how do we get this? I know there are a lot of things going on in this slide already. We have tan theta to be equal to P over Q and tan alpha to be equal to Q over P. The inverse of tan theta equals to cot. So if you have our tan alpha to be equal to Q over P, we are going to have cot alpha to be equal to P over Q, and that equals to the tan theta. What we have here is P over Q, and what we have here is P over Q. So that is how we get that tan theta equals to cot alpha. So let me clean this off. So now, how do we define our complementary angles? So let's go back to this part where we have that alpha equals to 90 minus theta. So here our sine theta will now be equal to cos alpha, and alpha equals to 90 minus theta. You see how simple that is to get. So our cos theta is now equal to sine alpha, and alpha equals to 90 minus theta. And lastly, tan theta equals to cot alpha, and alpha equals to 90 degrees minus theta. So this is how we get our complementary angles. Sin theta equals to cos 90 degree minus theta, cos theta equals to sine 90 minus theta, and tan theta equals to cot 90 minus theta. As I said before, there are a lot of things going on in this slide. Take note of each part and let's look at some examples. Now let's look at how we can apply these rules. We have an example here. Say, in which of the following ways can you express sine 65? So we are given sine 65 degrees. From the rules, we know that sine theta equals to cos 90 degrees minus theta. So we already know that cot is not going to work. So this is not going, and also this is not going. So we now have cos 25. So we can say that sine 65 equals to cos 90 degrees minus 65 degrees, and this equals to cos 25 degrees. So another way we can express sine 65 will also be equal to cos 25 degrees. Let's look at another example. Express tan 40 degree and for cos 40 degrees in terms of cot and sine respectively. Now looking at the first one, which is tan 40 degrees. So we know that tan theta equals to cot 90 degrees minus theta. So if you have tan 40, this will be equal to cot 90 degrees minus 40. Therefore tan 40 degrees will be equal to cot 50 degrees. Now let's look at the second one, which is cos 40 degrees. Also we know that cos theta equals to sine 90 degrees minus theta. So therefore we have cos 40 degrees to be equal to sine 90 degrees minus 40. So cos 40 degrees equals to sine 50 degrees. And if you try to press this in the calculator, we are going to see that tan 40 and cos 50 gives us the same answer, and also cos 40 and sine 50 gives the same answer.